Hey everyone, welcome back to my channel. Today let's take a look on 1293 shortest paths in a grid with obstacles elimination. This one is quite similar and can be an upgraded version to 1091 shortest paths in binary matrix. And the only difference there are is firstly you can go from previous 8 directions, 8 adjacent cells to now only 4 directions. Let's move up, down, left, and right in one step. And secondly, there are obstacles whose value is 1, and you can go over them, but that will consume your elimination number. And every time you will be given a grid matrix and also k times elimination, which means you can eliminate at most k obstacles in a specific path. So your job is to return the minimum steps you can walk from. Let you walk from up left corner to lower right corner. That task is basically the same. And let's consider this question. So firstly, if we just think about how many ways you can go from 0, 0 to 3, 0 to 2, 0. So firstly, you can go straight down, right? Go through this one obstacle. That will consume you one time of elimination. And you can also go to the right first and go down and then go left. This one will take a longer path, but will save one elimination for you. But eventually you went to the same cell, but with different elimination times left. So you need to record your elimination times as a state for each cell or each specific path. So let's take a look how we achieve that. Firstly, we also need to have a queue. We have a result. We have a visitor check bullet. And if grade 0, 0, we'll also record the elimination time here in our queue. One more thing is visited. So this should be like this. And we also need to remember every time we visited a cell with how many elimination times left. . let me firstly complete this structure. If this while loop doesn't give you any result, you will return -1. That means you didn't find any path. And otherwise, you will firstly get the queue size every time and make a for loop inside this while loop. And pull a integer array every time from this queue. Let's call it current. Sorry, we also need to have a direction array. Because this time we only got 4 direction. And for integer, this should be a matrix. What about times? Let's call it elimination times. Actually, we will minus its value on grid, right? And if now we need to check the XY for bound. Also need to check if we have visited this point or not. So firstly, we need to make sure our elimination time is greater or equal than 0. Only this we can make it into our queue. And we also need to check if we have visited it before. After each for loop, Let me the layer. We need to add our result. Oh, I forgot something actually. I need to check if current 0 equal to grid length -1 and current 1 equal to grid 0 length -1. This one mainly help us check if we has reached the bottom right cell. If so, we need to return the result. And let's see if it works or not. Yeah, it says we're auto bound. Yeah, so this one might have to go inside this one. Yes, it works. It's not that hard if you have a clear mindset. Yeah. Use BFS, use XYR, where I is the remaining number of obstacles you can remove. Exactly the same way we use. So, thank you for today's watching. If you enjoy, please like or subscribe, and remember to recommend to your best friends. Thank you.